Hi, I'm Bob Dukish, and I wanted to show you a couple of projects that we'll be working on in communication electronics. A couple of the projects that we'll be playing around with a little bit, working with and learning how transmitters work, receivers work, and also about the electromagnetic spectrum. We'll learn about that, and we're going to start things off with audio.
Well, this is a amplifier here. We're using a 9-volt battery right now. Rather than normally we use 5 volts for a lot of the projects in the book here, but this 9-volt battery works a little bit better for a little louder response from the speaker. The speaker, whoops, it's got a little feedback. That speaker is not a full fidelity speaker, obviously, so we're going to be kind of limited as to how that thing sounds. And I'm pretty far away from it, and I can hear myself through the speaker. I'm about 3 feet away. Let me get closer. Hello, test, check, 1, 2, testing, 1, 2, 3, test. Not very high quality because it's just a real basic circuit, but it shows us how the microphone works. It's an electric condenser. You have to supply a DC to make this thing work because this microphone has a little amplifier, preamp I guess you would want to say, and then that goes into a power amplifier, and that's a LM386 IC. It's an 8-pin IC. And you power it up, and one of the outputs is the audio. It's real simple. You can change the gain of it too, which means you can vary the volume. And I have it up full blast, and that's why we're getting feedback here a little bit. Hello. That's also why it doesn't sound real good. You know, it's over distorting a little bit, over modulating. Hello, check. But it sure does work. So that's one of our projects. So this next project, this is an infrared transmitter and receiver. And what we're showing is that infrared signals, like you would get from a remote control for TVs and things like that, you know, they're light. It's a light, but it's not visible. It's outside of our range of seeing the pulses. But what it's doing actually is sending out a series of pulses. That's what our program is doing. The Arduino, by the way, is unnecessary. It's just providing power. There's no program for this project. We're using a 555 timer. It's an NE555 is the part number, and it'll just flip-flop back and forth at whatever frequency we'd like to set it up for, and we have this set up for 38 kilohertz. That's the frequency of remote controls for TVs and things like that. So that's pulsing out the light that's infrared that we can't see out of this little blue LED. That's an infrared LED. It's sending it out this way. Then next door to it, facing the same way, we have a receiver. And that receiver is going to react to 38 kilohertz pulses. So if I get a reflection, it's going to turn the red light off. That's the way we have it set up. It could be the opposite way, you know, it probably should have been, but we have it so that if there's no signal coming back, the LED, the red LED is on, and if we do get a return pulse, the red LED shuts off. So I'm going to put just my hand, I don't know if you could see my hand or not, there's my hand, and it's going to go toward that transmitter and receiver, and a couple inches away there. Let's see, yep, there it goes, the light's off, right? So I'm about kind of at a weird angle, but I'm at probably about 4 inches away. See, and then when I move my hand out of the reflective area, now the light turns on, it gets the reflection, the LED turns off. So this is kind of a project that I like because it shows that, you know, while it is infrared and it is line of sight, it's also it has some reflective properties, just like regular light does. You know, it can reflect. Then we're going to modify this project and have it so that we do actually from point A to point B. So we'll have to use 2 breadboards, and we can send digital pulses and even do control, like control different operations like a remote control. So we'll basically be building a remote control. And I think we might use the Arduino because we could get a little bit of a better response. This thing runs on 38 kilohertz. Closest I could get that 555 is about 37 kilohertz, so it's a little bit off. That's why it doesn't have that great of an operation. You know, a couple inches, 3, 4, 5 inches maybe. And if you use a piece of paper, let me just grab a piece of paper real quick. Okay, it's supposed to be a short video, I know, but here, real quick piece of paper. It's going to be a white piece of paper, so it's going to have a little more reflective property. See, I'm further away now, maybe 6 or 7 inches. Well, you can't see, I guess, but I'm 6 or 7 inches away, and you know, now I can get that reflection a little bit better. So those are just a couple of the projects that we'll be working on. I'm looking forward to it. Boy, we're going to have some fun. Okay, see you in the fall.